respected dignitaries and invited guests. Good afternoon and hearty welcome to one and all. We have gathered here this afternoon for the felicitation meeting on the successful completion of the ISRO Respond project titled Prediction of Process-Induced Deformations and Residual Stresses in Fiber Reinforced Composite Laminates. Dr. Suraj K. Prabha has been the principal investigator of the project, along with Mr. Praveen A.P., co-principal investigator, and Mr. Shins K., assistant professor and JRF as the team members. Today we have with us Padma Shri M. Chandradattan, former director, BSSC, and honorary advisor of Vidya International Charitable Trust, along with other invited dignitaries. Let us begin the program by seeking the blessings of the Almighty.
ദൈവമേ കാത്തുകൊള്ളുന്നു കൈവിടാതങ്ങു ഞങ്ങളെ നാവികൻ നീ ഭവാബ്ധിക്യോരാവിവൻ തോണി നിൻപദം ഒന്നൊന്നായി എണ്ണി എണ്ണി തൊട്ടെണ്ണും പൊരുളൊടുങ്ങിയ നിന്നിടും ദൃക്കുപോലുള്ളം നിന്നിലസ്പന്ദമാകണം അന്നവസ്ത്രാദി മുട്ടാതെ തന്നു രക്ഷിച്ചു ഞങ്ങളെ ധന്യരാക്കുന്ന നീയൊന്നു തന്നെ ഞങ്ങൾക്കു തമ്പുരാൻ. ആഴിയും തിരയും കാറ്റും ആഴവും പോലെ ഞങ്ങളും മായയും നിൻ മഹിമയും നീയുമെന്നുള്ളിലാകണം. നീയല്ലോ സൃഷ്ടിയും സ്രഷ്ടാവായതും സൃഷ്ടിജാലവും. നീയല്ലോ ദൈവമേ സൃഷ്ടിക്കുള്ള സാമഗ്രിയായതും. നീയല്ലോ മായയും മായാവിയും മായാവിനോദനം. നീയല്ലോ മായയെ നീക്കി സായുജ്യം നൽകുമാര്യനും. നീ സത്യം ജ്ഞാനമാനന്ദം. നീ തന്നെ വർത്തമാനവും ഭൂതവും ഭാവിയും വേറല്ലോതും മൊഴിയുമോർക്കിൽ നീ. അകവും പുറവും തിങ്ങും മഹിമാവാർന്ന നിൻപദം പുകഴ്ത്തുന്നു ഞങ്ങളങ്ങു. ഭഗവാനെ ജയിക്കുക ജയിക്കുക മഹാദേവ ദീനാവന പരായണ. ജയിക്കുക ചിദാനന്ദ ദയാസിന്ധോ ജയിക്കുക. ആഴമേറും നിൻ മഹസാമാഴിയിൽ ഞങ്ങളാകവേ ആഴണം വാഴണം നിത്യം വാഴണം വാഴണം സുഖം.
Now we invite Dr. Saji CB, Principal, Vidya Academy of Science and Technology, Talakotagara, for the welcome address.
Yeah, thank you, Divya. Am I audible?
Yes, sir.
Yeah, thank you so much. President of the function, our chairman, Dr. Santosh Prasannan, most respected guest, Padma Shri M. Chandradattan sir, honorary advisor and former scientific advisor to Chief Minister, former Director of VSSC. Persons of attraction today, Dr. Suraj K. Prabha, Dr. Praveen, and Mr. Shins, who have been the persons behind executing the project successfully. Our chief patron, Engineer P.K. Ashokan, honorable dignitaries who also would be addressing us today in this gathering today, other trustees, members of the executive committee, members of board of directors, senior administrators from both Vidya Kilimanur and Thrissur campus, invited guests, members of Vidya family. This very special occasion and this very special function for us. We wish to share our joy with this elite group about a remarkable accomplishment achieved by the institution. We have successfully completed a project funded by the Respond scheme under the Indian Space Research Organization, ISRO. This project was titled Prediction of Process-Induced Deformation and Residual Stress in Fiber-Reinforced Composite Laminate. We have received a fund of rupees more than 13 lakhs for this project. The project was actually sanctioned in November 2017, though we have started our background work much earlier. Further details about this project will be shared by Dr. Suraj Prabha during the course of our discussions. We have requested and invited these elite members to join us today for sharing the joy of this special accomplishment, to express our gratitude to the stalwarts personalities who have enabled us to accomplish this goal, and also to felicitate the faculty members who have actually executed the whole project. And it was because of the unparalleled guidance and support from Padma Shri MC Dattan sir that we could get this pioneering project at the very beginning. And the continuous guidance has helped us in completing the project as such. We also remember the technical support from Dr. Gangan Pratap, Dr. Anil B, Professor KB M. Nambudripad from VSSC, etc. These contributions were invaluable to us. Finally, the team headed by Dr. Suraj Prabha as the principal investigator, Praveen as the core researcher, as a co-investigator, and Mr. Shins as a JRF. The team worked really well, really hard, really very systematically to complete the project in this successful manner. Later, as I said, we'll also listen from Dr. Suraj more about the experiences of the journey throughout successful completion of this project. Expressing our gratitude to all of you for joining today, let me also extend a formal word of welcome to each one of you. President of the function, our chairman, Dr. Santosh Prasannan, has joined us. He'll be presiding over the function. A warm welcome to you, sir. Let me also extend a very warm welcome to our most respected guest, Padma Shri M. Chandradattan sir, who has been always our guiding light, motivation for completing this project from the very beginning, as I said, from taking up this project and completing this project. Dr. Suraj K. Prabha, Dr. Praveen AP, and Mr. Shins, you are the persons who have worked really hard, made this possible. Together, let me extend a hearty welcome to all three of you to this function. I would extend a hearty welcome to Engineer P.K. Ashok, our Chief Patron, our author trustees, members of Executive Committee, and Honorable Board of Trustees, members from the Board of Trustees, Engineer G. Mohanachandran, our Honorable Advisor, Executive Director Shri Suresh Lal, Engineer R. Devarajan, our project director, Shri P.N. Undirajan, our director administration, Dr. Anil B., academic director, Professor K.B.M. Namboodiripad, our visiting professor, Dr. Devi Kumar, principal of VAST TC, Dr. Sudha Balagopalan, Dean Academics, Dr. V.N. Krishnachandran, Vice Principal, and Dr. N. Ramachandran, Head of the Mechanical Engineering Department, Head of the persons who have been actually working on this. All other heads of departments and senior members from both Thrissur campus, senior administrators from both the campuses, head of VTC, head of VSEC. I'm happy to extend a very, very warm welcome to each one of you to this function. Let me also welcome all our invited guests and members of Vidya family who are here to share with us. We hope that this is only a beginning. We know we have more and more to go forward. More similar projects has to come. We request blessings from each one of you in our journey forward, and we thank once again for joining us. Welcome to you. Thank you so much.
Thank you, sir. Dr. Santosh Prasannan, the chairman of Vidya International Charitable Trust, is presiding over this function. We invite Dr. Santosh Prasannan to deliver the presidential address.
Thank you, Ms. Divya. Padma Shri Dr. M.C. Dattan, former director of VSSC, scientific advisor to the Chief Minister of Kerala, and our honorary advisor, Dr. K.B.M. Namboodiripad, visiting professor of Vidya and former dean at Amrita Institute, Dr. Anil, our academic director, Mr. Mohanichandran, our honorary advisor, Mr. Suresh Lal, our executive director, Mr. Devarajan, our project director, Mr. Unirajan, our administrative director, Mr. P.K. Ashokan, chief patron of Vidya, Dr. Saji, principal of Vidya Academy, Dr. Madhavraj, principal of Vidya Academy Technical Campus, Dr. Sudha Balagopalan, Dean Academics, Dr. Krishnachandran, Vice Principal of Vidya Academy, Dr. Ramachandran, the head of the Department of Mechanical Engineering, and of course the stars of today's function, Dr. Suraj Prabha, Mr. Praveen, and the rest of the staff of the project team, other eminent members of the faculty and staff at the Vidya campuses, my colleagues at the Executive Committee of Vidya and other Vidya trustees. Good afternoon to all of you. I'd like to thank everyone once more for attending this felicitation function today, where collectively as Vidya family, we are acknowledging and congratulating the successful completion of a great research project headed by Dr. Suraj, Mr. Praveen, and others. Research, as we all know, is the backbone of the engineering domain, whether it's in academics or in the industry. Research paves the way for new and improved materials, products, technologies, processes, and innovations. The research conducted by Dr. Suraj and his team is a great example where the team looked into certain important properties of fiber reinforced composite laminates. Such FRP composites have tremendous use in the automotive and aerospace industries, as pointed out in their report. By the way, I had the privilege of reading their research report, and it took me back to my days when I was doing research, where I was looking at some properties of another composite material, concrete. Dr. Suraj, we look forward to your summary presentation of the project later during the program. I'm sure that the work done by Dr. Suraj and his team will enable further advancement and research in the field of FRP composites and its properties. At Vidya, we have realized the importance of conducting research both at the faculty level and in the student level several years back. In this regard, we acknowledge the tremendous support, guidance, and advice given by several eminent people, including Padma Shri Dr. M.C. Dattan, Dr. K.B.M. Namboodiripad, Dr. Gangan Pradap, our research director, who unfortunately could not be here today, Dr. Anil, our academic director, Professor Narayanan Komarath, and others. The importance of research is also highlighted in the new national education policy, which is put forward by the central government and which included the creation of a national research foundation. In order to streamline the research and development activities at Vidya, we have restructured two initiatives. One of them is the formation of a Vidya Research Center, VRC, and the other one is the restructuring of the Vidya Talent Center. Both are currently functioning in full swing with a clear vision document and action plan. Dr. Suraj Prabha is heading the Vidya Research Center, and Dr. Kala is heading the Vidya Talent Center. We have started the operations in the Thrissur campus, and very soon we'll be extending these activities at the Kilimanur campus as well. In research, one of the major focuses we are doing is in the area of undergraduate research. We realize the importance of introducing research initiatives in the undergraduate level, a thought process which has taken deep roots in the in USA and several Western countries. So the process of student projects which start during the final year has been restructured to make it more practical and focused. In addition, we have introduced student projects right from the first year level onwards. Dr. Sudha is taking a big initiative in that at the Thrissur campus. And we plan to further strengthen this program in the future. In addition to that, we plan to have more sponsored research to be undertaken by our faculty. We hope to win and perform more significant research projects in the future, which will be beneficial both to the society and to the industry. So with this, I have great pleasure to invite everybody and thank everybody for attending today's function. We look forward to hearing the felicitation addresses by Professor Padma Shri Dr. M.C. Dattan and all the other dignitaries who are present here today. Thank you very much.
Thank you, sir. Today, we are honored to have the valuable presence of Padma Shri M. Chandra Dattan for enlightening the function. This project could be realized because of the constant support extended to us from Dattan sir. We invite Padma Shri M. Chandra Dattan for the special address.
Thank you, Dr. Prasannan. Thank you, Saji. It's a very nice occasion today. Good afternoon to all the Vidya team members who are all present here in this function. I told it's a very pleasant situation in the sense it is celebrating a success by the team. In fact, my association with the Vidya institutions started in 2014. Ashokatan was instrumental for that. And I remember the first program I attended at Thrissur College was the graduation day, somewhere in 2014 middle. Now coming to this today's program, the felicitation of the team members for the successful completion of the program and project. I won't take much time. Anyway, Dr. Surya and the team, Dr. Praveen, both are going to give a clear presentation about what is the type of work. But I will just give an introduction to the type of work. As Dr. Prasannan has mentioned, composite material. It was in 19th century only the composite material has got introduced in the engineering field, because of which lot of other advantages over the metallic and ceramics and such kind of materials. As the name says, composite is made out of different materials integral to a single material like that. In ISRO, this technology has been introduced by Dr. Kalam during 60s. And in Trivandrum, Paturkavu, later, we have started a facility there for making composite products for the satellites and launch vehicles in different systems, in different modules. It has come to a very high level of expertise now, after years of work there. I am not a composite man, but I happen to be in the campus, for about 4 years. So I have a link with those people and about the facility. That really helped for helping to Dr. Suraj and Praveen for getting a respond program from there. First of all, though I'm talking about non-engineering people, composite is a very interesting subject. How the human mind has got to the technique of composite, because by looking at the nature. In the nature, whatever we are seeing is composite. Simply look at the coconut tree. The coconut tree, the stem, the leaf, everything is composite. It is designed by the creator for that purpose. You just look at the ola and even an olacal. It is stiffened by in the middle by a rigid piece. Very, very interesting thing. And human mind has copied those things and understood. Make a material having different material with different materials having different properties. Some materials will have, tensile properties more. Some materials will have compressive properties more. And these combination, etc., made the composite structures. It will be having a reinforcing agent and a matrix. The simple form is concrete. Simplest form of the composite material is concrete. Concrete, when we are telling PCC, without reinforcement, it may not be as an example. But with reinforcement, RCC becomes a real composite by the steel bars taking the tensile load and the other portion giving the compressive load. But the processing of the composite is a very, very tricky job. Very tricky job. And often, during the processing, there are chances for getting into defective piece. Our subject, today's subject is concentrating on finding certain methods for optimizing the process conditions. Process conditions means in the composite, there are different types of fibers we use as a reinforcing agent. It can be fiber, fabric, or 3D form. When we say fiber, it is a unidirectional thread. ഒരു നാരിനെ നമുക്ക് fiber എന്ന് പറയാം. അത് രണ്ട് directionലും weave ചെയ്തെടുക്കുമ്പോൾ it become a fabric in X direction and Y direction. But now there are 3D, 4D, 5D preforms are available. For heavy structures, for extreme load-bearing properties, we make composite from 3D preforms. That means neither by X and Y in direction, Z direction weaving on down. So that is a special kind of reinforcement made for making extra strong materials, especially the heat shield materials, nose cone materials, which are undergone to high temperature during the re-entry of the vehicle. We use carbon-carbon material. It's a composite carbon-carbon where these kind of 3D preforms are put. Anyway, the problem what the manufacturers faces is only mainly the curing aspect is there. Curing means, see, the matrix will be in the liquid form when we apply over the fibers. And after the orientation of the fiber in place and the matrix applied, it has to be cured for solidification. During that particular period, a phase change happens. That phase change is going to be very tricky. It will have a problem. For making a product, a composite product of any shape, any complicated shape, we require a tool. We can call it as a mold. The shape of the mold, the material of the mold, the way of laying the fibers and application of the matrix, and the cycle, cure schedule we call it, the cycle by which the heating is done, and finally after attaining the curing is over, after cooling. These things are all very, very critical. If this is not done properly, many times the products get in with defects and get rejected. We can't do repairing on a composite product is very, very difficult because it will not get the original property. In the satellites and launch vehicles, we get lot of systems where the composite material is required, especially for reducing the weight. The advantage of the composite material is high strength weight ratio. And bottles, gas bottles we do is propellant bottles, nose cone structures, interstage connectors, solar panels, antenna panels. So many things are all being done here. But the problem is the rocket and satellites, when we get the product and assemble together, the dimensional accuracy is extremely important. For attaining the dimensional accuracy with the micron level, we should be extremely careful in designing the mold, the tool material on which we embed the matrix as well as the fibers. And during the curing and cooling, we should be extremely careful. And during the presentation, you may come up to the 2-3 times. I will just give some layman's understanding. I will tell you, he has also told vacuum bagging. Vacuum bagging is a technique we are using in the composite processing curing process. In the curing process, because these layers of fiber or fabric, one over the other, you lay it and then apply some pressure in the atmospheric condition, and then you put it there. After curing, what happened is the matrix I mean is the resin, and the fiber has got two different coefficient of linear expansion, CTE. So it may expand or it may contract different way. This is the problem giving item. And there is a tendency for the fiber or fabric to get delaminate. That delamination is a major defect which will spoil its total characteristics. So vacuum bagging is a technique used for applying pressure inside by 1 bar pressure we apply by creating vacuum inside. So that externally it is having 1 bar pressure and it is covered fully with a vacuum bagging, and then you suck it so that you create a positive pressure over the layers of the fiber. That is called. And even in the oven also we apply pressure. There are bigger products which they are not supplied, they are not applied, but we used to use autoclave. Autoclave is curing with the pressure. Up to 20 bar pressure, we apply over the product during the curing. For nozzle components, very, very ablative components, we apply up to 80 bar pressure by water pressure. That is called hydroclave. It's a very specialized equipment only for these programs. And this hydroclave, when you apply that pressure, the compaction of the fabric, and the reinforcement and the matrix is extremely good, extremely, very, very compact it will come. Now their work what they have done is they have made a tool for making a sample specimen with the glass epoxy. Epoxy is the matrix, and the glass fiber they have used, the unidirectional fiber they used. And that laying pattern, the orientation of the fiber, the material of the mold, the tool, that also is important, because that also, the mold also has got a different CTE. That then it will become a 3-component system: the fabric, the matrix, and the mold. So these 3-component systems, the delta E difference, behaves in a different way. 3 things happens, there is, after taking out the product from the tool, we find spring in. they will be explaining a term spring in. Spring in means, see, in a curved surface, if you take it there, etc., once you bend a material, and it may go back to the original position. So that tendency is called the spring in. So what happened is, if we take an antenna structure with a particular curvature and make it, and once you remove it from the mold, the tool, it goes in a different dimension. This is very difficult for us to do it. So we should have a calculation and an analysis to see that after cooling and removal from the picture, how much spring-in will happen, and give allowance according to that. Warping is another problem what we generally find in the composite things. So spring-in, warping, and residual stress. These three things they have addressed. Residual stress is the internal thermal stress created in the product, which also gives problem once it is used by application of loads during the actual use. So the residual stress are also to be reduced to the minimum. There are methods for that. They have tried also, and also for measuring the residual stress. That residual stress measurement by drilling the hole and then embedding the circular strain gauge, etc., they have done enough. I understand enough experiment they have done it. There also they have made. Ultimately, the experimental data, whatever they got it, they have converted to a theoretical modeling and analysis, so that with this data, it can be extrapolated to the various similar systems. That is the one which has given advantage for the ISRO's program. I also, before coming here, I just had a discussion day before yesterday with the concerned engineers there, very young, talented engineers, etc., who were participating, Sanjeev Kumar and Hari Krishnan. Both, at my time only, they have been recruited there. And both of them are extremely happy with the work. And also they told, usually institutions, when they get the respond program, they don't take it as very serious. And ultimately, for the sake of getting the budget, they make the report, somehow they complete the report and submit and close it. But this particular work is a good quality work. And for the ISRO's ongoing composite production programs, this can be used. It can find a good place in the technical area. That is what the information I got. So I was extremely happy. And I take this opportunity to congratulate Dr. Suraj, Dr. Praveen, and I understand that there was a very smart junior research fellow who has worked for 2-3 years throughout the program and completed all the activities and trials. So Vidya can be proud of completing this work within this slightly more than 3 years. And especially from ISRO. ISRO getting a respond program is not that easy. And even after getting the program, the formalities they have to complete by satisfying the people who are guiding from ISRO, is very difficult and tough. But they have overcome all those things and done an excellent job. So I take this opportunity to express my high appreciation to the team and also to Vidya Academy for sparing their total resources for this kind of research work. As Santosh has very rightly pointed out, an institute of Vidya standard cannot exist and survive without giving special attention to the research activities. Research activities is a must. And all faculty members, it's a very humble request that all faculty members to make shorter groups, to have discussions on different innovative themes, and have something may come up positively, something may not come up positively. Don't bother about it. With these few words, my time is over. I just concluded the things by thanking once more to all the team. Thank you.
Thank you, sir. A journey of 1,000 miles begins with a single step. The key to realizing a dream is to focus not only on the success, but the significance. And then even the small steps and little victories along your path will take on greater meaning. To take us through the project, we have with us Dr. Suraj K. Prabha, the principal investigator of the project. We invite Dr. Suraj K. Prabha to take us through the project.
Hello. Hope I am audible to you. Expected.
Sir, it is not audible.
Am I audible now?
Sir, if voice is very feeble.
Okay. Hello. Is it okay?
Yeah, it is okay now.
Okay. In fact, I had a problem with the connection, but we have enough people to present the presentation here. So, respected chairman.
Louder, please.
This function, Dr. Hello.
Sir, your voice is breaking. It is not, it is very feeble also.
Can I take a
You
minute
can
to
switch
change
off your
my
video.
connection?
Suraj, you can switch off your video and see whether
Okay.
you can do so.
Is it okay now?
Yeah, better it seems.
Yeah. Okay. Respected Chairman, Dr. Santosh Prasannan, our honorable guest, Padma Shri Chandrayathan sir, respected Principal, Executive Director, all other dignitaries present over here. Good afternoon to one and all. In fact, we are overwhelmed with joy to present our work in front of this elite group and the nice words and feedback that we have received from Chandrayathan sir. It has been a wonderful journey for the last 5 years. In fact, the official duration of the project was only 2 years, but it took almost 5 years to complete the journey. Still, some official formalities are remaining here. So for today's presentation,
sorry, Suraj. Can you be a little more louder?
Hello. Hello.
Yeah, voice is feeble. Can you go louder or closer to the mic?
Hello. Hope it is. Is it audible now, sir?
Yes.
Yeah,
Now it is loud.
Yeah, please go ahead.
Loud and clear. Loud and clear.
So for today's presentation, we have got two parts. One is the technical content and another one is the journey through our project. So regarding the technical part, we thank you, our honorable guest Chandrayathan sir. In fact, everything we wanted to say in the presentation have already been covered by Chandrayathan sir. Now it's only a presentation of the details. So in ISRO, we had a lot of presentations in the due course. So I have been presenting there for the entire duration. So for the today's presentation, I give the opportunity to my co-investigator, Mr. Praveen, who has been there with me for long. So the technical part will be presented by Praveen, and may I invite Praveen, with your permission, to present the technical part of this presentation. Praveen, please.
Thank you, sir. I hope that I'm audible.
Yes, sir, you're audible.
Thank you. Let me share this screen. I hope the slide is visible.
Yes, sir, we can see.
Okay. So first of all, thank you, Surya sir, for inviting me to present the technical content of our project. So this is a topic, the prediction of process-induced deformations and residual stresses in fiber-reinforced composite laminates. So myself, Praveen, and Shins is our JRF and my student also, and he also joined here. And so Sanjeev Kumar, he is the scientist, is a co-investigator of from BSSC. Okay. So let me begin with the composite, the first part, that is laminated composites. So as Dathan sir has already mentioned, the very simplest form of composite is a concrete. And Chairman sir also mentioned concrete. So a composite is a material. Okay. So generally in engineering, materials are classified into two, that is metals and broadly classification, right? Metals and non-metals. So the non-metal part, again, they are classified into ceramics, plastics, then composites. So in composites, which is composed of more than one materials, and we will get a final product, those properties are definitely better. So here we are focusing on laminated composites. Means a composite has two different parts, that is a reinforcing part, and another one is matrix part, or a continuous medium. So if you are reinforcing a fiber, that is called a fiber reinforced plastics. Okay, here we are using a polymer, that is epoxy. And our material was glass reinforced epoxy resin, or glass epoxy composites. So compare with other metals or metals composites. So laminated composites have several advantages, like its high strength to weight ratio. Dathan sir has already mentioned. That's why the carbon composites are generally used in outer space vehicles and several components in the aerospace vehicles. But also then there are several applications like prosthetic limbs, that fiber boards, recent automobiles. We can see several components made of carbon fiber reinforced composites. So in the composite world, we are facing a lot of difficulties or challenges, like to maintain the dimensional stability. That is a major cause or major drawback of this particular laminated composite, and also its repairing techniques. So we are focusing on that issue, that is dimensional instability of a laminated composite or glass epoxy composites. So basically two different terms, that is spring-in and warpage. So what is spring-in and what is warpage? These two are the two different dimensional inaccuracies or dimensional drawbacks of fiber laminated composites. The first figure, it is self-explanatory. Suppose you are fabricating an L-shaped composite. After curing or after processing, its shape gets distorted from the initial shape of the mold. And that delta theta, that is the spring-in angle. Okay. Similarly, for a flat plate, it bends sometimes in the upward direction or in the downward direction. That is called warping. So our project is prediction of process-induced deformation. Let me explain. Prediction of this induced deformation, that is spring-in and warpage of fiber reinforced composites. Okay, so we are trying to predict this deformation of fiber, that spring-in and warpage in fiber reinforced composites, and we are trying to model it through FTA software. So this is our objective. So basically, we have proposed a lot of, we have proposed objectives, and in 2015, then with the help of the scientists, we have revised it several times, and the objective has been set for first year and second year. So the first year, we are going behind the spring-in and warpage. We were going behind the spring-in and warpage. That is, we have to fabricate a composite, then we have to measure the spring-in, then we have to simulate it, then you have to model it mathematically. And the second year, we were going behind the stresses, or why the spring-in is happening, due to the residual stresses generated inside the material during the curing process. So how will you measure the residual stresses? Is it possible? Is it possible to measure the residual stresses? Or how will you measure residual strains? Then how will you convert the strains into the stresses? So there are a lot of questions. Then how will you simulate this condition? These were the objectives in the second year. So let's go to the fabrication of composites. So we have fabricated glass epoxy laminates in our composite lab at ISRO. Thank you, management, team, and Vidya for funding for the curing oven. So the reinforcement was e-glass fiber and the matrix was an epoxy. And this is the dimension of the two we have fabricated. And we have fabricated the composite using two different tools. Tool means molds on aluminum and also on mild steel. Why? Because these two materials, that is aluminum as well as mild steel, they have two different portions of thermal expansion. And this portion of thermal expansion affects the spring and warpage of the composite. So that is one of the important parameter, parameter causing spring and warpage. And this is the cure cycle. Cure cycle means, as Nathan sir also mentioned, the importance of autoclave in fabricating a composite. So here we are having a very small scaled autoclave or a curing oven where we are applying a pressure and temperature like that way. So we are increasing the temperature and for 4 to 5 hours you're keeping it steady, then to atmospheric temperature, gradually reduce the temperature. So that is a cure cycle. The cyclic variation or the variation of pressure and temperature has been plotted, and we have fabricated different composites on stack, 04, 030, all of them are symmetric composites. Now the next question is how you measure the springing. That was the next problem. The most important part is whenever you keep that fabricated component in the shell for a long time, it will absorb moisture and you will lose the spring. Okay, so you fabricate it, you directly go to the lab, then you measure the spring in between in between very fastly. So we have searched everywhere, and we went to NIT Calicut. They have a CMM facility, and we have measured the included angle between the composites. Parallelly, we have tried another method, that is 2D image analysis using Python codes, using best fit lines. That is also another method. We have tried to find out the included angle between the two flanges. There are different methods, like 3D scanners can be adopted worldwide to find out the inclination or the angle between these two flanges or the spring in between the composites. Now, to understand that mechanical properties, why? Because these properties are very important, that these are the input parameters for our simulation. So we have to find out the mechanical properties of the composites. So we have prepared these composite materials. So we have prepared a large composite. So cutting into the space, this small specimens, as per the STM standard, that is another difficulty. So that is a disadvantage of composite. We cannot machine it by using a diamond condenser directly. So we have searched everywhere, and we find that the water jet, abrasive water jet machining, that's the best method. And we find some places, and we went there and we got that specimen to STM standard. Then we analyzed. Then the tests were conducted at the CIT Trivandrum and MC University, Kochi. Now coming to the simulation and modeling part. So we are trying to mimic the physics in our simulation part. There are a lot of software, APS softwares are available, like ANSYS, as well as Altair Hypermesh. So this particular problem, we are not applying any forces or any other constraints to the problem. I mean, any other forces, external forces. These are process induced. That means the fabrication technique itself creating the stresses inside the material. So that particular module is available in Abacus only. So that Abacus was not available here in our college, and which is a very costly software provided by Dassault System. Therefore, we requested ISRO, and they have agreed, and they allotted particular slot for us to join there and work with them. And we stayed there, and we run our simulation at ISRO, and we have taken the results. And we have used C3 DHT model, Abacus element, that is a 8-noded brick element. Now we have applied all the input values by using micromechanics. So this is the final result what we have received. You can see that we have simulated the spring. This is an accelerated view. We can see the spring in angle. Why not the entire rail is not modeled? Why? Because of symmetry. For symmetry, only half of the structure has to be modeled. That is a fundamental of FEA. Okay. there is no need to model the entire structure. We have to model, we have to take the advantage of the model, thereby reducing the number of elements so as to reduce the calculation time. So now there are a lot of parameters like input parameters like modulus of velocity, shear modulus that I have not included in this slide. Now this is a validation of model developed. So the developed model has been validated with the experiments, and the trend was really encouraging. Now coming to a dimensional analysis, we were trying to create a mathematical model based on the results obtained from the simulation as well as from the experiments. So we have used a fundamental Buckingham theorem for creating a mathematical model for springing. And these are all the parameters we have selected. These are the influencing parameters we have selected, and these are the dimensional formulae. And by applying the principle of Buckingham pi theorem, we find out that spring angle is a function of all these 6 independent dimensional steps. Okay, we can reduce it further by using more experiments or statistical analysis. Now coming to the second year, that is the residual stresses. The residual stresses, how do you measure the residual stresses? So it's not possible to measure the residual, stresses directly. First, you have to measure the strains. So there are different methods are available, like destructive methods, non-destructive methods, like that. So we have searched everywhere again, and in BHEL, Trichy, there is an experiment set up with it. That is incremental Hall-Drilling method. That is a semi-destructive method, where we are fixing different strain gauges. Strain gauges at different places, and we are measuring the strains by drilling a hole. The concept is very simple. By drilling a hole, the strain gets released, and that strain has been measured using the strain gauge, and we are plotted. Okay, so these are the results. By going to deep, that is 10 mm, 1 mm. Okay, 10 steps for 1 mm. We have found out the variation of stresses like that. Okay. So as I already told, this is variation of stresses. What we have received is strain value. The strain value has been converted to stress values using micromechanics or CLPT, classical laminate plate theory, by multiplying with ABC metrics, and as usual, that is calibration coefficients. And these calibration coefficients are obtained from Abacus. Yeah, we have simulated the Hall-Drilling, the entire Hall-Drilling process using Abacus. Then we created that calibration constant, then multiplied with the strains, then we get the stresses, then plotted for different composites. That's the second year. So the first year, these were the deliverables and linkages, right? The first year we have completed the fabrication and spring-in calculation and spring-in measurement, mathematical modeling of the spring-in. The second year, we went for residual stresses, and we have measured the strains, and we converted the strains into stresses. And all those objectives were complied. And we have proposed some countermeasures in terms of material parameters and process parameters to ISRO. And this model is capable of predicting the deformation, that is spring-in angle of a composite, if you know the effective CT of a composite material. Well, these are the summary. As I already explained, the fabrication has been successfully completed, and we have measured the spring-in using that is CMM, that is coordinate measuring machine. Then also using Python codes, that is 2D image analysis. Then we have simulated it using Abacus. Then also we have created the dimensional model and mathematical model using dimensional Buckingham pi theorem. Then we have measured the residual strains, then converted to residual stresses using that is incremental Hall-Drilling semi-destructive method. Then we have simulated the same using Abacus. Then we have submitted all these programs to ISRO for their future projects. Thank you. Thank you very much. Thank you very much for giving this opportunity to explain the fundamental details of our project. Over to you, sir. Suraj, sir.
Okay. Thank you, Praveen. Can you please upload the next part of the presentation?
Sure, sure.
Play the slides.
So visible?
Yeah. visible. Thank you. Thank you, Praveen, for the presentation of the technical part. Now, let me explain the experiences while the journey through the ISRO Respond project. Next slide, please. Yeah. So these are the important dates for the ISRO project. In fact, our work we have started in late 2015, and proposal submitted in 2016, and after first revision, second revision, third revision, etc., the project got approved in 2017. So one can notice that actually it took almost 2 years after the submission to get it sanctioned, which means that if you have the problem in hand, if you have the proposal ready, then it may take maybe minimum 1.5 to 2 years to get it approved by the sanctioning authority. For any industry or any people, anyone who is working with projects, past data is the only reliable source of information that we can trust with. So with this experience, one can understand that if you decide to apply for a funded project, it may take minimum 2 to 3 years to get it sanctioned. Why I'm pointing out this is means actually one must be patient enough to cross those periods, and one must have constant enthusiasm to do all the revisions, all the proposals given by the sanctioning authority. It may not be the case with all the funded projects research organization. From organization to organization, this thing can vary. Again, when it comes to submission, our closure report was sent on 21/9 or in September 2020. So again, then one more small formalities are remaining. That is, we are yet to get the closure certificate. Everything has been done. So I had contacted ISRO people for that. So what they were telling that they are also locked down with the ensuing pandemic conditions. Their Trivandrum office and Bangalore office also. Once the conditions get improved, these formalities will be complete. That is the information that I have received. So it took almost 5 years, and still the journey continues. Then next slide, please. Yeah, this is the summary of the project. All these things have already been mentioned by the Praveen and those who have introduced the subject. So our amount was 13.414 lakhs, and one manpower was there. Official duration was 2 years. Next slide, please. Yeah, this is the journey to day one, because from the beginning of the project, from the beginning itself, actually the day one, we decided to write a proposal to ISRO. Then from the day one to the official start of the project, as I have mentioned earlier, a lot of work we had done in between, right? We had a presentation at VSSC in 2016. Then we had undergone some 2-3 revisions. These are all official revisions. In between, we had revised the manuscript many times by discussing with KBM sir and other people, whoever is there at our reach. Then from the submission of the project to day one, I repeat, it took 2 years. Next slide, please. Next. Yeah. So in between, actually, we had done a lot of preparatory work for doing the project, because we all were not well versed in composites when we were decided to write a proposal. So we had to do a lot of work in between. So Praveen and Shins had registered for Swayam courses, which is considered to be PG level courses, and they have secured elite certificates in those courses. In fact, Shins was topped. Shins had topped those courses 2 times. Then we had attended a lot of workshops, whatever is available in between. Then there was workshops in Abacus in Chennai. Then of course the preparatory work in VSSC also. Then Bell, all those things were they're done for the project. Next slide, please. Yeah, these are all the certificates, because all these certificates are valid for the career as a career improvement or achievements, because all these SWAYAM courses can be considered as 1 week FBP or equivalent things, and all these things are input to our outcome-based education calculations, right? So why I am telling all these things means that actually all these things may not be surfaced for people who are looking from a distance, right? Next slide, please. Yeah. Apart from all those preparatory work, which is supposed to be a part of any research work, because in any research work we cannot start a research work by preparing each and everything aspects of that. Then it will not be a research project. Research project, we have to inquire things about, seek things whatever is necessary, and we have to find people who are capable of doing that, and a lot of things are there that all of us know. But we had faced a lot of unforeseen delays in the first and second phase of the project, and I have tried to portray it in the slide. Again, when we received the sanction order, we had no facility to fabricate a composite here. Earlier, ISRO had agreed to provide composites for testing and all. They will make the composites and they will give us the composite. That was the assurance they had given in the earlier stage. But then they have told that it's not going to happen. You make your own facility and do it. That will be better for you. So we started searching facilities. So the searching facilities, we were, and the initial stages, we were trying to outsource the fabrication process, but we were not able to get any suitable facility at our reach to fabricate the components that we need. That means we have to match the cure cycle. Then only the components can be fabricated with all the dimensions and process parameters. So we decided to set up our own curing system. So we had made given order for the curing system, and it is a custom-made curing system. Whatever is available in the market or in the small-scale industries or any engineering units, they are not accustomed to build this kind of ovens which controls temperature and pressure simultaneously. And in addition to that, we had to apply vacuum also. So we have to have facility for vacuum. Then we have to have facility for applying pressure and temperature. So by simultaneously applying all these things, we need to go for the custom-made oven, and it got delayed some 7 or 8 months due to this customization process. So what we are losing is the time allotted by ISRO. Only 24 months are there officially. So in that 24 months, if you are losing 7 months for the oven itself, because without oven we cannot start the work. Then another challenge was getting materials. Getting materials in small amount was not a feasible option, because whenever we try to get quotations from vendors, they are asking about how many tons you need, but we need in grams or kilograms. But that also is a problem. Then shelf life for this is a problem. Then we were trying to get the prepregs for the dimensional accuracy, but storage and transportation of this prepreg is also again a problem, and that is also not available in small quantities. Then there was a simulation part. We had done attempts to outsource the simulation because we don't have the license of Abacus, so we need to get the work done at any cost. So we were trying to outsource the work by giving all the input, technical input, but just run that input as per our direction, and we will pay for that licensed version run. That was our attempt, and we have realized that is not possible. So we started to search for the other options available. Then again, material testing, that is also a challenge because we had tried many options. We had been to MG University, we had been to CET, we had been to PSG College, but none of them has the exact facility that we needed. But somehow we managed to get the specimens get tested, and some of the tests were failures also. Then again, as mentioned by Praveen, actually the cutting the composites is a troublesome process. We had to go for the abrasive jet machining to make it into the standard form. Next slide, please. Yeah. Second year, actually, this is unfortunately late in the second year, right? In second year, if you have noticed, our work was concentrated with the measurement of residual stresses. So in the presentation, technical presentation, you might have seen a small instrument which is used for the drilling purpose. So when we talk about drilling purpose, we cannot drill the composites with the usual drilling machine that we have at our lab. Maybe those drilling machines are operating in the range of 3000 RPM or a few thousand RPMs. Even if you go for a custom-made thing, possibly, if you are lucky enough, you may get drilling machines of maybe 10,000 RPM. That is the maximum that you can get from the industry if you go for the custom-made thing. But the desirable RPM for drilling these composites for measurement of strain is probably in a few thousand, as high as 50,000, 70,000, or even 1 lakh. So that machine, which you can see in the presentation, technical presentation, small machine that is capable of doing 1.5 lakh RPM, which is there in the bell, and that is the only facility that is at our reach. So we have been constantly approaching them for a permission to visit their industry and have a technical discussion. So we ran behind them 7 months to get an appointment. I repeat, to get an appointment, not for the work getting done, but to get an appointment to discuss the matter. Finally, they have allowed us to give an appointment, and we went there a couple of times for the technical discussion, and finally they have agreed. Not because that actually they have to make money by consultancy work. Actually, probably they might have been pleased with our enthusiasm to do this. Then again, I was talking about Abacus simulation. Nothing was going in our way. So again, we approached VSSC for providing a couple of weeks. So they were asking how many hours you need that. But with a few hours, maybe 1 or 2 hours, our problem would not have been solved, because we need to make a lot of simulations to get the data for the mathematical modeling. So 1 or 2 hours, or maybe 1 or 2 days also is not a feasible solution. So I was asking for 1 month. So the people concerned told that it's not at all possible. You reduce it. Then I asked for at least 2 weeks. Then also they told it's not possible. Maximum 1 week. That is the thing that we can allow, because all our machinery are 24/7 or maybe fully engaged. That's why. But finally, we were lucky enough to get 2 weeks of stay at VSSC, and we have utilized the entire duration there. then the thing is that actually after doing our work, we cannot take anything from outside, anything from ISRO out. That is a big problem. After doing all the work, again we ran behind them for from pillar to post, I would say, for 8 months, another 8 months to get the data, because whatever we had done, that was in the ISRO system. So we have to get a data from that. We cannot copy or email any data of those simulations. So for getting approval also, we have been constantly approaching different people, and finally we managed to get the data after 7 months. So all these period we are losing from the deadline. So one can imagine what would have been the pressure for completing the work in time, right? Because all these with all these unforeseen delays. Then again, in actually Praveen was the copy A in this work. He met with an accident in the fag end of the project, and he was not, his service was not at all available for maybe 7 or 8 9 months, almost 8 months, totally zero input. And after the fag end of the means at the when it was about to close, he was also restless that he is not in a position to contribute. So that also was a difficult period for us. Then again, JRF, who was sincerely working with me, with us, got an opportunity to do PhD in IIT Madras. So I was pleased to send him in the applied mechanics department. So his service also was not available at the end of the project. Then for myself also, I had some personal issues at home, so I was also not able to join the college for more than 1 month. So this period, which you can see all red lines, that was a real test for us. Then again, the last one. Okay, Praveen, next slide please. All of us know the COVID situation was there. After the presentation at ISRO, they had mentioned some changes in the report, not in the presentation. So that also was not able to complete in time lockdown, because in March we had the presentation, February we had the presentation, and March we faced the first lockdown. And we were able to get a few publications from this. One is one on IIP series, which is published and available online. Another one is in the review process, which is already been selected in the conference, but it's from journal to conference, that is under review. And one paper is under preparation. We are about to upload that paper. Next slide, please. Then actually, with all these difficulties, there are some outcomes, tangible outcomes, or I would say the immediate outcomes, not the long-term benefits, immediate outcomes for Vidya. We could achieve some one third project from this work assessed in the form of student project, which also been successfully completed. Then publications, which I have already mentioned. Then maybe some 8 to 10 batches completed their UG project work in line with the objectives set by this project. Then composite fabrication facility, we have got a composite fabrication facility, even though it is in the primitive level. Then contribution to MBA like things. Actually, we have been trying to get NBA accreditation for all branches. For as far as mechanical branches are there, with this project, we are contributing to the points in additional facility creation, funded research projects, publications, additional courses. All these things has got some points in relevance fields. And with this project alone, we could achieve a lot to the contribute to the project. Then overall improvement in the research and modeling or skill sets of the people who are involved. Then again, we could derive another proposal, solid research proposal from this as an extension of this work. Again, I would mention that actually the PhD admission was based on the proposal that we have submitted to IIT Madras. So that was this work. So he is working in experimental stress analysis but in a different problem. Next slide, please. Yeah. Finally, the acknowledgement part. Actually, there are a lot of people helped us during this course, so it is very difficult to mention all their names. So we have mentioned, we have seen a few people who have helped us are already present there, but there are some organizations which helped us in this journey. That is, one is of course VSSC itself, because even though it's a response project, they have no obligation to help us, but in many ways they have helped us to accomplish the objectives. Then another one is Bell, Bharat Heavy Electricals at Trichy, that I have already explained. Then NIT Calicut, we had the coordinating measuring instrument facility was there. For this instant, at this instant, I would like to thank our HOD Ramendra sir also, because he is the person who contacted the person concerned there, and he agreed to work on a Sunday, and we could do our work on a Sunday, right? Then MG University, the university campus, we had been there for a couple of times. Then of course CET. Then Rotek Instruments is the industry who made this custom-made oval. Then again, of course, needless to say, the support and the guidance of Vidya International Charitable Trust. Yeah, next slide, please. Thank you. So these are all the unforeseen delays. Actually, this is the things probably that is the eye-openers. Many other things for the people in Vidya, because whenever we go for next project, these things we would anticipate in our way. Then only we can find light at the end of the tunnel, right? When we start a journey. So that's all from my side. With this, I take this opportunity to thank the Vidya Trust College and everyone who has helped us. Again, principal was mentioning about the help of Brahmadan sir, Chandradhan sir. Then again, I take this opportunity to thank our always our motivation, like Namburipat sir. So our journey started long back ago, but still continues. Actually, that is the greatest blessing that we can get from this campus, I would say. But there are a lot of people. Then another person of significance is Dr. Usha. She had also helped us a lot. I am mentioning the people who had contributed technically to this. There are many other people who have supported us in and out of the campus. Of course, we had no problems from the management or college in executing this. That means official delays. So we are thankful to the college team, principal, management, and executive directors, Mahanendan sir, Suresh Lal sir, everyone. But still, if I take the list of people who have helped us in this project, it's very long. Since due to time limitations, we have already crossed our limitations allotted time. But still, let me thank one and all for organizing such a function to felicitate us. Thank you, sir. That's all from me.
Thank you, Suraj sir and Praveen sir, for sharing your valuable experiences. Now we move on to the felicitations. We invite Engineer P.K. Ashokan, Chief Patron with the International Charitable Trust, for felicitating the audience.
Sri Narayana Paramagurave. Good afternoon to all of you. I am very happy to join this function today. We are all here to celebrate the successful completion of an excellent research project. Expression of gratitude is very essential in a teamwork. And we in Vidya, whether faculty or trustee or managed directors, all belong to one team. Still, we need to express our gratitude to each other and also to acknowledge what we achieved. It is not to boost our ego, but to maintain our self-esteem, acknowledge our capabilities. I'm very happy to join this evening with you all today. Dr. Suraj Papa and Dr. Praveen are the persons, and of course there are a few others, who work beyond time limits to make these projects successful. Looking back, I remember the days when Dr. Subramaniam was the principal here in Vidya Science and Technology, Vidya Academy of Science and Technology. At that time, we have been selected to do one wonderful project by the Kerala University. Also, we started research work in our campus with association with Tamil Nadu University, and also we had a few registered guides. That was the first stage. In the second stage, we were fortunate to get associated with the global famous scientist, Padmasri M.C. Rattan, Dr. Gangan Pradhapan, Dr. K.B.M. Namboodiripad, and all. We are fortunate to get connected with all of us. KBM, we always remember, and you all be remembering his own words. There is no teaching. There is no teaching in the campus. It's only learning. And research is the process of learning. And that culture still remains. And I am happy KBM is here. And his voice will again be continued and create positive energy in the campus. And at this stage, this is a stage 3. Dr. Saji is fully active in developing the centers of excellence, which the Vidya International Charitable Trust dreamed for years. And he has developed a good teamwork with the HODs. And Dr. Saji is encouraging the youngsters to do wonderful things beyond limits. And I'm just cutting short because of the time limits. There are few other dignitaries to express their joy and gratitude for this event. Congratulating again Dr. Suraj Papa and Dr. Praveen. And I wish Gurudeva blessings and God's blessings for their continued growth. And Dr. Suraj Papa, as you all of you know, is an excellent leader. He has all the qualities needed for a leadership. Leadership, whether it is in research or in social work or whatever, the nature remains the same. The basic quality, the God-given quality is the natural intelligence and acquired knowledge and readiness to work, cooperation to all around, and patience, tolerance. All these qualities are greatly blended in Dr. Suraj Papa. I state this because of my personal contact with him occasionally. And I wish the team, Dr. Suraj Papa, Dr. Praveen, and Dr. Sajian team, and Vidya team, all success in the coming years to serve the humanity. Thank you.
Thank you, sir. Now we invite Engineer G. Mohanachandran, Honorary Advisor with the International Charitable Trust, for felicitating the audience.
Thank you. Thank you, Divya. Can you hear me?
Yes, sir, we can hear you.
Okay, thank you. Dr. Santosh Prasannan, the presiding officer of this function, our very distinguished guest, Padma Shri MC Chandradattan, our very respected Guru, KBM sir, other dignitaries participating in this online meeting, including Dr. Anil, Dr. Sudha, our principal, the principal of the other college, head of the departments, especially the head of the department of the mechanical engineering department, other faculty members, and the team members of the research, of the project team headed by Dr. Suraj Prabha. I am extremely happy to participate in this meeting and getting the details of the project completed by the team, and also the importance of the subject and its relevance explained by our chief guest, and the difficulties and obstacles faced by the project team during the execution. I'm very happy because I was a silent spectator throughout their journey from the day one to this date. We were told by the evaluation committee of the first NBA visit to concentrate on two things mainly. The areas in which Vidya campus are lacking. One is project, other is research. And they also advise to focus on quality publications. After that meeting, and that meeting coincided with the joining of our former honorary advisor and research director, Dr. Gangan Pratap. He also attended the review meeting. At that point, only this the importance of the funded projects and research struck me very very hard, I must say. From that day onwards, I was encouraging all the faculty members to get themselves engaged in some sort of project works, whether it is student project or funded projects or departmental projects, whatever it may be. And a few of our faculty members were very cooperative, and they started writing proposals. And one of our senior faculty members of that time, Colonel Indiyudan, has taken the responsibility of conducting it regularly. And naturally, the then all such initiatives, and to add that, in the very next year, we got the service from Dr. KB Anil. Coinciding with the joining of KB Anil, I think it is in the same month or the next month, the team under Dr. Suraj Prabha came with this proposal. They presented the proposal first before a high-level committee of Dr. Gangan Pratap, KBM sir, Dr. Anil, and principal, the then HOD, etc. With their advice and guidance, they decided to go ahead, and the KBM sir, our chief patron Ashokan sir, they were in constant contact with our honorary advisor MCD sir, who gave the right directions to proceed. That part was the known part of the story. And I am here to highlight only one or two points. I need at least an hour to describe about the kind of preparation Dr. Suraj and the team made in approaching this project. After getting the
Hello, can't hear anything. Dr. Sajji, there is no audio.
Sir, you are not audible.
Yes, sir, we are conducting. Meanwhile, Divya, you can call the next person.
sorry, yeah. Now I think you can hear me.
Yes, sir. Now we can hear you.
I was talking about the kind of preparations the team was making.
Dr. Sajji.
Yes, sir.
Do you have the problem in hearing?
Sir,
No, I can hear. Dr. Sajji, I have a small request. Your project fellow was Shin. I could not see him. Is it possible for him to come and just people can see?
Yes. Shins, please switch on your video.
Yes, sir, sure.
Shin, why don't you tell a few words?
Yeah,
your
sure,
experience.
Sir. Yeah, sure, sir. Respected dignitaries, a very good afternoon to all. First of all, I would like to thank Vidya for giving me this great opportunity. Actually, as I have told in many places, my relationship with Vidya has begun during my +1, +2 days. For those who don't know about me, I did my BTech also in Vidya. So after my MTech, actually I joined here as an assistant professor. Only I joined after I joined here, only I came to know about this project and this opportunity. Since my MTech project was also related to the composite materials, I decided to attend the interview and I got selected. That's how I became the part of this team. So to me, it was a great experience. These 2 years, I could learn a lot of things from the team. Yeah, my ambition was to become a teacher, but I was not clear. I was not very much clear about what are the other kinds of work which I need to do as part of this profession. And also I was not clear about the importance of research in academic life. So all this I could learn during this period. And I remember with gratitude all the lessons which I could learn during this period, and remember the technical sessions given by KBM sir to all of us. Thank you, sir, for that. And at last, but not the least, Suraj sir, whatever I did during this period, it is only because of the guidance and support Suraj has given to us. And definitely it is because of the motivation, experience and exposure which I gained from this project. I could get an admission in IIT. So to me, the biggest outcome from this project is me only with an update which is who's updated with some additional skills. So once again, I thank you all. Thank you, Vidya. And I wish this be a good starting for Vidya, and that more and more research projects come to Vidya. Thank you.
Okay, thank you. Good
Yeah,
work.
thank you so
Okay,
much,
proceed.
Shiv. In fact, there has been another Shins is a synonym to that. Thank you, Shins.
Thank you, sir.
Thank you, Shins, for sharing.
Vivek,
Yeah. Thank you, Shins, for sharing your experiences. Now we again go back to Engineer G. Mohanachandan, sir, for felicitating the audience. Sir, can you hear me?
Thank you, Divya. I got some connection problems, so I
Okay,
think I would better conclude by giving all the and best wishes. Yeah, best wishes to the team, and also the wishing the college and other faculty members every success in their attempts in this. So with this word, I conclude, because I don't think that I cannot continue for long, because the connection is breaking off and on, and also my own sound system. Okay, thank you everybody for giving me this opportunity to witness the felicitating ceremony of Dr. Suraj Prabha, Professor Praveen, and our own boy Shins. There is one more person to be felicitated. That is Mr. Anshad, who is the heir of the other project, where the team was taking up two major projects simultaneously, and both the projects were completed successfully and met all the parameters, like the project results, the fund, the papers, and the elevating the JRs as PhD scholars, both of them. Thank you everybody. Thank you the organizers. Wish you once again, wish you very success. Thank you.
Thank you, sir, for your words of encouragement. Now we invite Mr. Suresh Lal, Executive Director, Vidya International Charitable Trust, for felicitating the audience.
Thank you, Vidya. Am I audible?
Yes, sir.
Respected dignitaries and Vidya family members, a good afternoon to you all. Today is a very important day in the history of Vidya. We could successfully complete a prestigious research project for ISRO. Dr. Suraj Prabha was the principal investigator for the successful completion, and Dr. Praveen, co-PI, and Mr. Shins Yaraf. Nice to see you again, Shins. He looks very good now. As we have seen from the presentation, a journey through the project, it was not an easy task. It was a real eye-opener for many of the people, including myself, who were not associated with these research projects in the past. Dr. Suraj and the team had to travel off the beaten path because there was no precedence to follow, and there were so many hurdles. So they had to go to many different institutions to complete the project. I congratulate Dr. Suraj, Dr. P.N. and Shin for successfully completing the project, overcoming all the hurdles. As our chairman rightly said, Vidya have recognized research as an important activity, and we have included it as one of the pillars of our Vidya growth plan. Now, to promote research, we formed a new vertical, Vidya Research Center, and Dr. Suraj will be heading that vertical. Dr. Suraj has already initiated a few steps to promote a research culture in the campus. We all need to extend our full support to Dr. Suraj to help him realize our dream of making India a major research center in the state. Once again, my sincere appreciation for the successful completion of the ISRO project, and wish Dr. Suraj and his team success in obtaining similar projects in the coming years. Thank you.
Thank you, sir. We invite Engineer R. Devarajan, Project Director with the International Charitable Trust, for felicitating the audience.
Thank you, Divya. Can you hear me?
Yes, sir, we can hear you.
Respected Chairman, VICT, the Tansar, Sogatan, and the other dignitaries who are present in the meeting. Good afternoon to one and all. First of all, let me express my sincere thanks to the organizers of this great function for inviting me to this function and giving me an opportunity to speak few words. I may congratulate Dr. Suraj Prabha and his team for this envious project they could complete, facing all the troubles and of course in the worst COVID situation. The work and effort they put has to be remembered always. And I hope that the successful completion of this project will definitely encourage others and motivate those many others who may come forward with new proposals, and they will be taking up new projects and elevate the name of our organization to higher and higher levels. As all of us know, in engineering, there are no limits for research and developments. While listening to the Tansar's words, a wild thought came into my mind. Well, actually, in electrical engineering, especially in transmission lines, we use steel wires for reinforcing our conductors for high tension lines. If we can replace that with a suitable lightweight material having better tensile strength, then definitely we can increase the span of the lines and reduce the construction costs. So the possibilities are there. So I just brought only one. Of course, we at the recent past, we have replaced the heavy insulators of porcelain with silicon rubber, and of course changed the heavy oil-filled bushings with oil-less bushings and so on. There are still more and more area where our budding scientists and engineers can do research and bring developments and improvements in the electrical engineering field also. And I hope that our people in both the campuses will be exploring the possibilities of finding out new products, introducing new products into the field, and improving the overall quality of our distribution and transmission systems. Once again, congratulating all those who work for this great project and hope that they will be continuing their research activities with more zeal. I am limiting my words. Thanks once again for giving me an opportunity to be with you for some time. And I once again congratulate all of those who worked for this great project. Thank you all.
Thank you, sir. We invite Mr. P.N. Onnirajan, retired IPS and Director Administration, Vidya International Charitable Trust, for felicitating the audience.
Good afternoon to all. Then respected chairman of the trust, who is chairing the meeting, a respected principal, then a respected Sri Datan sir, and other respected dignitaries and participants, and especially today's chief guests of honor, Sri Suraj Prabha, Praveen and their team. First of all, I use this opportunity to congratulate and compliment the team for their successful completion of the research on the subject composite materials. They have brought accolades to Vidya, and for that, then we are also obliged to them. Some 1 month back, I have read in a news magazine that in India, below 1% of the PG students are doing research. On the other hand, in alien countries, it is more than 12%. In that way, it is happy to say that our team has successfulully completed the research project. The work of the team should be an eye-opener to other faculties and students of our college. Then Datan sir, who has given a rhetoric delivered and given an explanation to what is a composite material. And then I think that then it was very interesting. When a layman can understand what is composite material, when Datan sir compared it with that of a coconut tree and along with that of the palm leaves of that tree. I think that it was very interesting, and I use this opportunity to express my thanks to Sri Datan sir also for making such a commendable comparison of this composite material, because as a layman, I was not aware of what is actually this composite material. So thank you, sir. Then I think it is because of this pandemic that then we used a live session, which should no doubt which should ought to have been a more interesting one. Anyway, I use this opportunity again once upon to express my gratitude and to compliment the new team for their successful completion. Thank you. Thanks a lot.
Thank you, sir. We invite Dr. B. Anil, Academic Director with the International Charitable Trust, for felicitating the audience.
Hello. Am I audible?
Yes, sir.
Okay. Respected chairman of the meeting, Ashwagatan, Datan sir, KVM sir, other dignitaries and members of Vidya family, Suraj, Prabha, Praveen, and members of the project team. Good afternoon to all of you. First of all, let me thank the organizers for inviting me to this function. It's always a pleasure to be part of such functions and felicitate the persons who are involved in the project. So first of all, let me congratulate Suraj, Prabha and the team for successfully completing this project, because for a self-financing college, it's a major challenge to get such a project, which they did. They, from ISRO Respond project, they got this project, and in a time-bound manner, they were successful in completing it. Because I know how difficult it is to get a project from ISRO. So when I was in CET, it was 70 years old institution. Even at that point of time, the number of Respond projects backed by the institution was only a handful. And other government institutions put together maybe 10 or 15 projects till that time. It is at that time, point of time, we went for constituting the Center for Engineering Research and Development, CERD, and I was fortunate to initiate the project, and I was the founder director of that. So in 2010, it was established. We can see a major change which has happened to the institutions. To take the example of CET, before the constitution of this CERD, and after that, there's a sea change. There was the number of PhD holders in the whole college was 20-25 at that point of time. But today, if you just look at the institution, more than 60% of the faculty are having PhD. Out of 300, 60% is a big number. A number of publications used to be 5 or 6 per year, but now that number has gone up phenomenally, exponentially, I would say. Today, the campus has more than 100 PhD scholars, full-time PhD scholars. So that is the impact which has made by promoting research in the institution. If you just look at the progress of an institution, the institutions which are coming up, their first task will be to fill up the seats. Then the next task will be to get maximum pass. Then next task will be to give maximum placement. And the next task will be to get research publications. If you want research publications, some research should take place. And later it will be maybe getting patents and things like that. So a top class institution, if you just look at, let's say, IITs or NITs, you can see that the research culture is already there. So I congratulate the management for supporting research. And without the support of the management, the faculty as well as the assets as well as the resources will not be spared for such research activities, because initially the results or outcomes will not be visible for the outsiders or the general management. If you just say what is the outcome, you will not be able to show it. Anyway, Suraj and Praveen has described it in detail, their journey through this, let us say, project. This is also commendable that they were able to finish it in 5 years. Even though the duration was 2 years, they were able to finish it in 5 years. But if you just look at the other response projects from other institutions, even IITs, you can see that the total time taken will be much more than that. So it's a great achievement for the institution. So I congratulate both the project team and the management. And I hope that this will be a motivation for other people to take up this project. And this particular program for felicitating the team itself is very nice, because one has to give a pat for the team to come up with more projects of this nature. And there is nothing like success. Okay, so they have succeeded, and this will be an example for others to follow. Thank you all.
Thank you, sir. Padmasri M. Chandradattan sir had to leave the meeting. In his absence, we take this opportunity to express our gratitude towards him for taking out time and attending the function. Now we invite Professor KBM Namboodiripad, Visiting Professor, Vidya Academy of Science and Technology, Talkotagara, for felicitating the audience.
Hello, can I be heard?
Yes, sir.
It's a great pleasure to be back again in India. I'm so pleased that my close friends and colleagues have completed what would be called a very, very formidable task. It is an uphill task, but they came up with wonderful results in the end. Now, I always say that I'm always convinced that the step from 0 to 1 is much harder then the step from 10 to 100. The first one project, a successful, good project, not 20,000 rupees type of project, a really big project of the kind of the Respond program is a difficult task, and it is a great, great achievement. So we have gone from 0 to 1. This first step is the most decisive step, and we have come good there. Now it's only a question of time before we go from step 2, 3, 4, 5, and so on. After some time, it will become a routine sort of thing. There's nothing much to write home about. It becomes like that. After 10 or 20, that's it. I am glad that we have come good, and we are not at 0 level, but we have come at level 1. From here, it is easy to take off. I am very proud and happy to say that, largely because of Suraj at an outer level. But really, it's not Suraj. It is actually the management has played a real role. I have seen several self-financing colleges, not one college is as serious in this. The management is so, they're fully, what shall I say? They're so fully sincere about this. They want to see that the institute comes up. And that is very, very different. And that is the reason. That is the reason why Vidya has come up. Of course, there are people like Suraj, no doubt. But Suraj is so much part of me that I do not feel like saying, to say good things about him is almost the same as saying good things about myself, which is sort of bragging. So I would not do that. But we had a wonderful team, Suraj and Praveen and Shins and Gafoor and whoever else comes to our lab. It's very nice. I wish that more people from Vidya, faculty members, who come and visit and spend a little time in the research lab. It's a different atmosphere. It's a different culture. It is, you don't distinguish between learning and doing and fun and everything. They're all mixed together. And that's the only way research can survive. You cannot say that I will do research between 9 o'clock and 11 o'clock. No, it doesn't like that. It goes throughout the time. And you mix up, what shall I say? It's a wonderful, wonderful research facility that Vidya has created. And how can anybody accomplish this without the active blessing and support of the management team? So I'm very, very happy to be back again with my colleagues in Vidya, but time is running short. I should cut it down sometime. I hope I'll come and visit all of you in person. Until then, we'll meet now and then. Thank you.
Thank you, sir. We invite Dr. T. Madhavraj Ravikumar, Principal, Vidya Academy of Science and Technology, Technical Campus, Kilimanur, for felicitating the audience.
A very good afternoon to one and all present in this online meeting. First of all, I would like to congratulate the entire team who has successfully completed this ISRO Respond project. And my special wishes to Dr. Suraj K. Prabha, who is the principal investigator of this project. And our ED sir rightly mentioned that's one of the pillar of VGP's research activities. So we will aware that, so we are focusing on that. And the success of this project definitely will motivate all the faculty members to engage themselves in the research practice in future. And also I add that, so such kind of research activities not only highlight the institution in academic activities, as well as it's useful for academic purpose also. So we know that, so this is essential in recent days in institutions. So with this, so we hope that such kind of research activities will be continued in future in both the institutions. So this I conclude. Thank you.
Thank you, sir. We invite Dr. Sudha Balagopalan, Dean, Vidya Academy of Science and Technology, Talkotagara, for felicitating the audience.
It's an immense lot of pleasure, as also pride and privilege that I have been given an opportunity to congratulate, as also felicitate not just Suraj Prabha, but his team members, that is Professor Praveen, Professor Rins, as also Professor Abdul Ghaffur. Perhaps we cannot see him separately as such. Way back in 2013, when we started thinking in terms of applying for respond projects, as it was next to impossible, exactly because of the reasons that were cited by not just Padma Shri MC Chandrarathan sir, but also our own academic director. But then Suraj had not joined our college. Later on, Suraj became our research phase, as I remember it, and as was pointed out by KBM sir, who actually introduced Suraj to Vidya. As was mentioned here, it was very clear. It is very clear that his team did a very elaborate as also difficult journey, starting from the point where the proposal was submitted. Later on, they weathered many storms, including perhaps onboarding of the people into the team, as also completing different phases of the project, and also ultimately even towards the submission of the project, because of several reasons, which are already cited. But at the same time, after all these difficulties, they have now hoisted a flag in ISRO, which is a matter of great pride for Vidya, no doubt about it. Moving on to the fact that the team reflected actually the theme of their project, in the sense that it was more or less a very composite team, in which each of the team members added strength to it. The words of the student members who were a part of the projects that were associated with this project also bears testimony to the same thing. In fact, one of those boys were talking to me sometime back, a few days back, and he was saying that he has chosen research as his career option. And I also noticed the very important research leadership in Dr. Suraj, in the sense that he has quite a lot of respectful mentorship, that is, in which there is equality amongst the mentors as also the team members. It is also, in fact, it was very pleasing to see that how he shares his glory, like we saw right now when the project was presented, the technical details were presented by Praveen, his junior in the project. He also tries to see that his team members are taken to the higher level, and that's the reason why both Shins as also Abdul Ghaffur are now research scholars in IIT Madras. So this is the way that things have progressed, and I'm very sure that that Suraj will not stop running, and him being selected as the research leader of our research group leader of our college now gives us hope to dream. Hope to believe that research will not come to an end. It will keep running, and we'll definitely one day will arise when perhaps we'll have what is called as what was mentioned sometime back by KBM sir, that we'll have a logarithmic rise. Perhaps we have gone from 0 to 1. Now it will be logarithmic in nature, and the research scenario in which we will progress to the level that the management has always aspired to. So I take this opportunity to again congratulate Dr. Suraj Prabha, Professor Praveen, Professor Rins, and the entire management, as also the supporters within the college and the mentors who are also here in this meeting for the excellent job which has merited.
Sorry, ma'am, we cannot hear you.
Still no?
Yeah, right now, yes.
Okay, so I suppose you have heard till now.
Yes.
Stop by congratulating again the team members headed by Dr. Suraj Prabha. Moving on to the mentors who have supported him all along, the college authorities, which includes the principal and the HOD and perhaps the entire staff members of the mechanical department, and perhaps a little beyond, and also our management. And I conclude.
Thank you, ma'am. We invite Dr. V.N. Krishnachandran, Vice Principal with the Academy of Science and Technology, Talkotagara, for felicitating the team.
Good afternoon. Good afternoon, all the dignitaries who are present here. My congratulations and great appreciations to Dr. Suraj Prabha, Mr. Praveen, and Mr. Shins, who have successfully completed the very prestigious ISRO Respond project. And this is a historical moment in the growth of Vidya as an educational institution. We are completing, or we have just completed, a centrally funded prestigious project. As Dr. Namboodiripad was saying, we have changed our status from 0 to 1. It's really a historical moment. Again, my appreciations to Dr. Suraj Prabha and his team. Listening to the talk by Padma Shri Dr. M.C. Chandradattan and also the presentations by Suraj Prabha and Praveen was a great learning experience for me also. Because I have not been involved in any type of projects earlier. So that gave me a great insight into how a project is being executed. I was sitting here, I was just wondering. See, the whole process started by starting a proposal in 2015. And it took 6 long years to come to a conclusion. 6 long years. I'm just wondering if the patience, the perseverance of the team which worked behind that project. I think they have worked even more than perhaps they have worked for a PhD. I was also wondering, what is a reward? What is a reward for the principal investigator and the team? Perhaps the only reward is the satisfaction of having accomplished something which was maybe previously we thought not possible in Vidya. We were all skeptics initially. Vidya has not developed to take up projects. So they have proved wrong. And maybe that is the satisfaction of having done something. Other than that, why I don't know, they are not getting any other reward for doing such a great work against such great odds. Not one year, not 2 years, just 6 long years. This team was behind one project. Okay, really, it's really appreciable and really commendable. Again, I congratulate Dr. Prabha and his team. So at this point, I would like to make a request to the principal. I would like to see this being presented before the entire faculty of the college. The presentations made by Dr. Suraj Prabha and Praveen must be made before the entire faculty of the college. This is my humble request, because every faculty member should know what it feels like doing a project. What are the odds? What are the difficulties? What are the challenges? What are the problems? How long it will take? What are the difficulties? So what are the difficulties they have surmounted? What are the difficulties faculty members have to surmount if they are going to do a project? So this will be a great eye-opener. It will be a great learning experience for all the faculty members of the college. So my humble request is, without delay, have a 1 hour session or something like that, where these distinguished persons may be invited to make a presentation for the benefit of all the faculty members of both campuses, of course, we can have a combined session. Faculty members of Vidya at the Thrissur and Kilimanjaro campus, both together. Okay, and that's all. I'm really happy to be part of this program, and also feel really proud of Vidya having achieved such a thing. And we are proud of Dr. Suraj Prabha, Praveen, and Shins. Congratulations. And thank you.
Thank you, sir. We invite Dr. N. Ramachandran, Head of Department, Mechanical Engineering, Vidya Academy of Science and Technology, Talakotagara, for felicitating the team.
Very good afternoon to all the dignitaries. It is a pleasure for me to be as a felicitator for the wonderful project which Suraj executed and completed, even though it took around 6 years of time. I know Suraj from the very beginning, from his undergraduate studies while he was at Calicut Regional Engineering College. Then his growth I had been observing silently as a teacher. Then when he joined the then NIT Calicut as a research scholar, then when I joined over here, I could observe him as the principal investigator of this particular project also. He used to explain and he used to mention that it was the blessings blessings which he could get from Monendra sir and Sudha ma'am, and the inspiration which he got from our KBM sir, which persuaded him to take up this project and execute in a very nice manner. And along with that, he was fortunate to have with him 2 gems, just like on a good garland, 2 gems added, Shins and Gafur. They also were with him, and Praveen also was 1 additional gem added. They silently and without looking into the time limits, they used to be in the laboratory, they used to be seen in the corridors, and whenever they are there, we used to tell Suraj is there and his research scholars are behind him. Afterwards, when Shins and Abdul Ghafoor got admission at IIT Madras for their PhD, I was not wondering because I know their caliber and how they worked in Vidya as research associates. It is indeed a pleasure for the department as such and for me to felicitate Suraj and the great team for this successful journey. As the head of research center, VRC, now he will be in a position to identify lots of projects. We also will be in a position to point to him lots of opportunities. Knocking at the right door only is the thing which has to be done. Now, lots of opportunities are there in different fields for research works which we will be in a position to fetch. There is no doubt about it. Only thing is that some enthusiasm, then good support from the faculty members. If there, we are sure to get more funding from different organizations, private as well as government and public also. We will be able to get good projects. So on behalf of the department and myself, a big salute to the team and its leader, Dr. Suraj. Thank you.
Thank you, sir. On behalf of the audience, we invite Dr. Suraj K. Prabha, Principal Investigator, for the reply speech.
Thank you. Actually, it's been long. We started our function at 2 o'clock. And now it's been 4:10. So there is no scope for a long reply speech, but I will try to cut it short as short as possible. First of all, although there is a vote of thanks function is coming, but it is my duty to thank everyone who has supported us. Again, as KBM sir has mentioned, without the support of the management, such a thing could not have accomplished in a self-financing college, because in 99% of the self-financing college, their motives or their objectives will be different from Vidya. So Vidya has a unique vision in that direction, so which helped us to execute this project, and that is the support we were getting from the management and from the college. So first, let me thank the management and the entire team in the college. I am not, due to limitations of the time, I am not citing everyone by position, but still. Then one more thing is there. Actually, during this project, I have worked with 2 executive directors, 2 principals, 4 HODs. Then when it comes to it, I hope 3 chairmans. So all those things is there in place. What I mean to say that we have to have a longer vision plan or longer planning for executing this type of projects in future too. Then regarding my team, actually principal investigator, co-investigator, JRF, these are all in papers. But when it comes to our lab, we all are equal, in the sense we all have their own space and their own importance. If you remove one element, then that is a void there. There is no replacement for that. So that is the importance for each and everyone in the team. Even though in the ISRO project, only 3 members are there officially, but our team was not 3 members. The JRF in the other team also was there in place to help us. Then KBMs are also there. So considering all these things, actually our team is bigger than what is there in on cards. And one more thing is that actually whatever be the glory that has been poured or the achieved or the appreciation poured on me, actually I am indebted to my colleagues, especially Praveen and Shins, who acted as my right and left hand in this project throughout the years. Even though Shinsuke has already joined in IIT Madras, he has been assisting me in completion of the report and all other matters that are related to research activities. So we all are, and Krishnandan sir was mentioning about what is the benefit for them. To me, I have something to add. We had a lot of memories that is cherishable throughout the year during these projects. Simply starting from the dine outs occasionally that we had together with the KBM sir. Whenever he is there, he will initiate for a dine out lunch or something like that out, which I found that it was very much essential. Probably he was initiating those things to not to keep our esteem low. He has to keep the morale of the team very high, right? Sometimes he keeps it with a single word or a phrase. So, and again, I was talking about his presence. Even though sometimes he may not be in a position to help it directly, but his presence itself is a motivation to do many things. Probably we can explain this thing by induction or with the Sankalpa. He might have thought that actually these people will do well in academics and life, which helped us to move forward. Then again, I am not dragging it too long. Again, I thank you all for supporting us, executive directors, principals, and the management, and of course the parent department, because even though we are officially in the mechanical engineering department, we have been exempted from many routine works for executing this project. So in numbers it will be there, but two of them are already not there physically. So that also may add a burden to my colleagues. So I have only one single appeal is there. Many have helped us in this great endeavor. Then in the meantime, if I have by word or by any justice, if I have made anything, given a wrong gesture or notion or any kind of things, please don't take it personal. It is due to the immense pressure that we are that we are on with the academic challenges ahead. Sometimes it might have happened, I don't know, but still I am taking an anticipatory bail. Hope you will understand that. That's all from my side. So once again, I thank you, and I thank the management for supporting us, and I also urge the management to support whoever comes in this path as you had supported us. That's all from me. Thank you.
Thank you, sir. Now we invite Professor Praveen AP, Assistant Professor, Department of Mechanical Engineering and the co-principal investigator of the project, to propose the vote of thanks.
Hope that I'm audible.
Yes, sir.
Pranam to all my gurus. Respected Vidya family, it's my privilege to have been asked to propose a vote of thanks on this occasion. First of all, let me thank God Almighty, who showered His immense blessings on us since we've been a part of this wonderful Mother Earth. I, on behalf of the entire ISRO project team, and I, on behalf, extend a very hearty vote of thanks to all eminent personalities assembled here. We express our gratitude towards Padmasri M. Chandradatan sir for his presence here today with us, and for all the motivation and encouragement he had offered for the project. Thank you, sir. I must acknowledge our deep sense of appreciation and gratitude to our chairman, Dr. Santosh Prasannan sir, Chief Patron Ashtokan sir, Honorable Advisor, J. Mohan Chandran sir, Executive Director, Sri Suresh sir, Project Director, Devrajan sir, Administrative Director, Uvirajan sir, Academic Director, and my teacher, Dr. Bianin sir, and the entire VICT family members for providing this wonderful platform for launching this project. I take this opportunity to thank our beloved principal, Dr. Saji sir, Dean Academic Dr. Sudha Balagopalan, Vice Principal B.N. Krishnachandran sir, for providing every support needed for the successful execution of this project. A big thank you to Dr. V. Madhavraj Ravikumar sir, Principal, Boas Kilimanor campus, and all the staff members for accepting our invitation to attend this program. I would like to extend my sincere thanks to our Guru, Sri KBM Maheshwar sir, for his excellent academic use, healthy criticisms, and support during each stage of the project. I wish to express our gratitude to our beloved HOD, Dr. N. Ramachandran sir, for his valuable suggestions and help, especially for testing this composite specimen during the project. Thank you, sir. Further, we are grateful to all our department members and everyone, including our students, who have supported directly or indirectly to execute this project successfully. Then I would like to take this opportunity to thank ISRO officials, especially the response coordinator, Sridharan sir, co-PI Sanjeev sir, and Hari Krishna sir, they are the scientists in the composite division, even their absence, for their guidance and critical reviewing this project. Finally, I extend my wholehearted thanks and gratitude to Dr. Suraj K. Professor and Sri Shims and Abdul Ghafoor for making this as a good team and for executing the project successfully. Finally, I would like to thank all the honorable dignitaries and guests present here on this occasion today. Thank you. Thank you very much.
Thank you, sir. With this, we come to the end of the program. Thanks to all who have graced this occasion with your presence. Thank you and goodbye.
Thank you, Divya.